Go ahead.
Awesome. All right, so Scapy is the third in the networking section. This is an awesome tool that lets you create packets of all kinds. So whenever you see alerts for a potential vulnerability that works with a malformed packet or a specially crafted packet, this is one of those tools that are used to do that. Earlier, we tested networking between our two systems so we know that it's running. So what we can start is right from downloading and running Scapy. Just like before, we can just copy and paste these commands that are already prepared for us and run them one at a time on our Linux system. So I will share my screen, and now you see my Linux system. Now that that's complete, I can copy the next line. That will install Git for me. When I see that complete, then I'll run the third line. That will clone the GitHub repository of Scapy into our system. Then we will go into the folder by typing cd Scapy, and then we will run Scapy itself. So you should be provided with a page that looks similar to this. And now we have the application running. Actually, I'm going to rerun it because I don't know why it doesn't show my screen properly. Because that's a little weird. Yeah, I'll stop my screen sharing for a moment. Okay. Reconnecting it, for whatever reason, it wasn't showing me the command line at the bottom, so I'm sure it kind of chopped off in the recording. So I'll go back into my Scapy folder and sudo /run Scapy. Awesome. So here we have our instructions. We're going to create a ping packet with Scapy. So in the terminal, we see the prompt with the three greater than signs. So we're going to type in this and then press the enter key. I equals IP and the parentheses. Oops, IP. Here, let me move this over. I'll make a new share of just this. Awesome. Yeah. Next, I will do i.display and do opening close parentheses because this is a Python program, and that will show us all the values that we have for this current packet. We see that it's a IP version 4 packet. We see right now the source and destination are both the local host. So we're going to change our destination. To do that, we'll do i.dst equals, and then we'll do google.com. In order to confirm that our changes are made, we'll do i.display again. And now see that what before was the local host now is pointing to Google. So now we'll move forward in creating our packet by typing IC equals ICMP, open and close parentheses. Oops, I put a dot where a dot does not belong. Now we can do IC.display and see the information related to a ping packet. So our first part was a lower layer in the OSI model that showed the IP, where it's going to go, what version of IP will it use. In this case, we're looking to see the type of ping packet. We're going to use a echo request, so that should be right. Now, in order to send our ping packet that we just created, we'll do SR, the number 1, not an L, and then in parentheses, we'll put I/IC for the packet that we created, our IP packet with ICMP. Then we'll hit enter. And that will have sent our ping packet out to the world, and we received a packet back. We see here, echo reply. That is not the packet we sent. We sent an echo request. And here you see that it finished sending the packet. So this worked. We successfully sent a ping packet out to Google and replied back a response. Now we can make some changes, which we're going to do as we near our first flag, the 430.1. And make a new share to show you where I'm talking about. So this is what we just did and successfully received our reply. Next, we're going to send another ping packet, but we'll change by adding this to our command. And instead of your name, the 2 words, you can put your name there. And when you send it, you should get a raw load, your name. So here, you can do SR, the number 1, parentheses, I for our IP packet, IC for our ping packet, and put my name there and close that. You can see here is my name. So far, so good. Now you have your flag, your upcoming challenge, where in a web browser, you'll go to this page, games.samsclass.info/temp/ping yourname.txt, and replace where it says your name with your name. The first couple of times you will get a not found, and that's okay. With Scapy, you'll change the destination like we did above. Remember when we changed the destination to Google? You'll use this same way to change it from Google, went too far, to ad.samsclass.info. And you'll provide this information from underscore Scapy underscore and then your name. This is not going to work immediately. You'll need to do a couple tries, but in one of those tries, you will get the flag and it will be covered in a green box. It will no longer say not found. Instead, you'll see your answer right here. Once you achieve this, you can move on to DNS with Scapy. Similar to what we did earlier, we'll set we'll create a DNS packet following the instructions already laid out. So I'll go here. I want to start all over again, so I will do exit with open and close parentheses. Again, this being a Python program, we need to add that. Then we'll do I equals IP. We'll do I dot our destination, which in this case will be 1.1.1.1. We're going to use UDP because that's what DNS typically will use. We're going to use DNS. We're going to make a DNS query. And again, I'm just following straight out from the instructions. Now that we did that, we can see what our packet looks like. Your result should look something like this, or very similar to what you see in your on the page. So we have an AIP packet with a DNS question to asking where is Google. To send this packet out into the world, we'll do SR the number 1, and then in parentheses use I, U, and D. Our packet goes out into the world and returns back a response. Right here. Google.com, www.google.com is sitting at this IP address. So just like that, we created a single DNS packet and sent it out to the world, and we got the right response. In the same way, you'll make some adjustments to your packet in order to find the IP address of flag0.samsclass.info, and the IP address that you will get back will be the flag. Then you'll look for the CNAME record of flag 1. That IP address will be the flag for that question. There's another DNS record containing a flag. And if you're stuck with this one, you can look at this link, the 8 most common DNS records, to find the flag for 430.5. And then you'll do a reverse DNS lookup for 1.1.1.1. And the answer will sit right here, covered in this green square. Again, you'll be making similar adjustments like you see up above here in order to craft the right packet that will return you the responses that are the flags to these next questions. And as always, if you have any questions, if you're stuck, please feel free to put that in the chat.